Assalamu alaikum. My name is Mohammedullah, and today in this video we're going to be discussing indices from Mathematics Syllabus D, CAIE GCE Syllabus 2021. So if any of you are not familiar with the term indices, it's basically the power of a number. For example, if I write 2 squared, which is basically 2 power 2, and this over here, this is an indice. So in this video we're going to be discussing all the laws and all the basic concepts of indices, and then we're going to be doing some practice questions for all the laws that we will have studied today. So the first rule that we're going to be discussing is the multiplication rule. This rule states that if x power a is multiplied by x power b, this becomes x power a plus b. There's something that you need to see in this rule, that there's a constant in this rule. The base number in both the numbers needs to be same, so it can't be 2 power 3 into 3 power 2. This rule does not apply to this because the base numbers are different. It only applies to, for example, if it's 2 power 3 into 2 power 4, only then does it apply. So what happens is, for example, if we just use this example, this will become 2 power 3 plus 4. So now I'm going to prove to you that this rule works. So for example, if I write x power 3 into x power 2, I can write this as x, which is basically x into x multiplied by x. So there's x power 3, 3x's, and x power 2, 2x's. And we know that the indice implies that the number is being multiplied by the value of the power. So x power 3 is 3x's and x power 2 is 2x's. So when we multiply these two, we get 5x's being multiplied by one another, which means it's x power 5. The answer is x power 5. So instead of doing all these steps, I can simply state that x power 3 into x power 2 is x power 3 plus 2, which makes x power 5. So this becomes x3 plus 2. The second rule is the division rule. This rule is similar to the previous rule, multiplication rule, but it's a bit different. It states that x power a divided by x power b becomes x power a minus b. Now again, just as in the multiplication rule, the base number needs to be constant, it needs to be the same. So let's take an example. For example, let's use the same numbers divided by 2 power 2. And here we can also write this as 2 over 2 power 2. According to this rule, this becomes 3 minus 2, which eventually becomes 2 power 1, which is 2. Now to prove this, let's write it as it is, which is 2 into 2 into 2, which is 3 2's because it's 2 cubed, over 2 into 2 because it's 2 squared. When we cancel out the 2's, we're left with 1 2, which is basically 2 power 1. So we can easily, instead of doing all these steps, we can easily assume that 2 power 3 divided by 2 power 2 is basically 2 power 3 minus 2. So this becomes 2 power 3 minus 2. This next rule is called the negative power rule. In this rule we see it says x power minus a is equals to 1 over x power a. So if we use an example here, 2 power minus 4, this will become 1 over 2 power 4. So the negative will become positive when it reaches the denominator. So we can actually use this power rule to prove a previous rule that we discussed, which is the division rule. This is the rule written right in front of you, but we can actually use the negative power rule to prove the division power rule using the multiplication power rule. Let me explain so it's not so confusing. So as we discussed in the previous rule, we can actually write x power a divided by x power b as x power a into x power minus b, because 1 over x power b is the same as x power minus b. And this, hence, as we learned in the multiplication rule, this power will be added with this power. Since it's multiplying and the base number is the same, this will become a plus bracket minus b. Hence it becomes x power a minus b, which is the same as the previous answer. So we proved the rule but using a different method. So this next rule is very simple. It states that x power a whole power b becomes x power a into b. So an example would be 3 power 4 whole power 2. This will become 3 power 4 into 2, which would become 3 power 8. The proof for this rule is first you need to remember what power means. Power is basically, for example, 2 power 2 is 2 into 2. So it's the base number multiplied by itself by the value of the power. So if we take this example, x cube whole power 2. So basically multiplying x cube by itself twice, because that's the value of the power. So it's going to be x, it's basically x cube into x. This becomes 6x's. And if we use the bracket rule to solve this, this will become x3 into 2, which is x power 6. And these are 6x's, which means x power 6. So the answer is the same, which proves bracket rule. This next rule is called the fractional power rule. In this, we use this rule to solve questions in which the base number has a fraction in its power. There's two ways of solving this. The first way, they're fairly similar, just a bit different. In this method, we have x to the power of a root to the power of b, and here we have x root to the power of b whole power a. Okay, so an example is, for example, let's take a basic example first. X power 1 over 2. So if we use this method, we can see here a is 1 and b is 2. So we can write this as, since b is 2, it's 2 x power 1. We don't need to write 2 here because this also already implies that it's a square root, and we don't need to write 1 either. So this is basically x square root. Next, the example is, what if it's x to the power of 3 over 2? It's the same thing, except now it's x cube root square root, and which is basically the square root of x cube. Now let's solve both these examples with the different method, which is the same method but with the different a bit different in terms of look wise. Let's use x power 1 over 2. Here it's going to become x square root, I don't need to write 2, whole power 2, whole power 1, sorry. This we're going to end up with x, which is the same answer. Next we have x 3 over 2. Here it's going to become like this, and when it's whole power 3, in the number itself is going to be cubed, not square root. So it's going to become x cube square root, which is the same answer. Last but not least, the zero rule. Even though it doesn't look very impressive, this is actually a very important rule when it comes to solving questions of indices. It's very simple. It states that x power 0 is 1. Actually, any number power 0, even if it's 2 power 0, if it's 3 power 0, if it's 97 power 0, anything power 0 will become 1. Okay, so the proof for this zero rule, we actually have two proofs for this rule. The first proof is, for example, if we take x power 4 and we divide it by x power 4. The simple proof is we can actually just cancel these two and it leaves us with 1. That's the first proof. The second proof is we just use this but solve it in a different method, which is x power 4 divided by x power 4. If we use the division rule, we're left with x power 4 minus 4, which is x power 0. So if this is equals 1, then obviously this is equals 1 as well. So hence we have x power 0 equals 1. In summary, these are all the rules that we've studied in this video, and now we're going to solve some questions in which we will use all of these rules. So this first question is the 20th question of, this is the reference, this is the 20th question of May-June 13, paper 1-1, and this is the code for mathematics D. So the question states that we have to evaluate this expression. So automatically, as we learned in the 0 rule, we should automatically write 5 power 0 as 1, because anything power 0 is 1. So this is 1. And 5 power 2 is basically 5 squared is 25. This is a very basic math, and this basic information, and you need to know this. Anything, all the squares you need to know. There are certain powers that you need to know by heart. So 5 square is 25, and 1 plus 25 is 26, and that's our answer to part 1. This next part, in which we will use the rule, fractional power rule. In this rule, in this question, we can see it's 36 powered 1 over 2, and as we learned, power 1 over 2 is basically square root. So let's write that. 36 is square root, and how we know this is from this rule. Let me just rewrite this rule here. So in here, a is 1, which we don't need to write, and b is 2, which we also don't need to write because it's implied by the square root. So now again, you need to know the basic roots, basic square numbers, and you would know that 36 can also be written as 6 squared. And since square root is, we can actually write in two ways. We can actually either cut these out, or we can actually write this as 6 squared whole power 1 over 2. Again, the bracket rule, and this will actually cancel out in such. 2 into 1 over 2 becomes 1, this becomes 6, and here this also becomes 6. So our answer is 6. In this third part, we can see it's written 2 power 2 over 3 whole power 6. It should be simple, as we write 2 power 2 over 3 into 6. So we can actually cancel out 3 and 6. We're left with 2. So we're left with 2. 2 into 2 is 4. So 2 power 4, which you should also know is 16. And that is our answer. In the B part of this question, we can see that this is a bit tricky question, and this is very common actually in papers, to find the value of k in such an equation. So the equation is 1 over 3 whole power k equals 9, and they have asked us to find the value of k. There are multiple rules being used here. First of all, we can see, obviously, it's an obvious rule here. 1 over 3 can be written as 3 power minus 1 whole power k equals 9. Now we use the bracket rule to multiply these two. This becomes 3 power minus k equals 9. Now again, using the basic knowledge of maths, you would know that 9 can be written as 3 squared. Now since both the base numbers is same in both ends, we can actually cancel these out, and we're left with minus k is equals to 2, and thus k equals minus 2, because when you multiply this whole thing with minus, we're left minus into minus is plus, and then minus into plus is minus, and then k is equals to 2, and that's our answer. Now on to a part of a different question. We have question number 6, part B of winter 1997, paper 1. It says to write down the value of square root of 0.004. Even though this looks difficult, it's actually quite easy. As we can see, 0.004 can be written as 0.004. In fractions, it can be written as 4 over 100. And if we write here, we can note that both 4 and 100 are squares of 2 and 5 and 2 and 10. Sorry. So if we write this as 2 over 10, we can write this whole thing as under root of 2 over 10 whole square. Then we can cancel out the square root and the square, and we're left with 2 over 10 or 0.2, and that is our answer. Okay, so this is a different question number 6 part B of October-November 2002 paper 1. This question asks us to find the value of n, and this is the equation: t into t cube over square root of t is equals to t power n. So basically we're just going to look at one side, this side, and prove that it becomes a single t power something. So let's take the left hand side, and t power 1 into t power 3. We're going to use the multiplication rule, and this will become t, since it's t power 1 plus 3 whole over under root of t under root, and this is equals to t power n. So t4, and now we're going to use the division rule, which states that we need to bring this up, but it's going the power of this t is going to be subtracted from this t. So 4 minus, since this is a square root, the power will be 1 over 2. So 4 minus 1 over 2. So this, I've basically simplified this whole thing into this, equals t power n. So 4 minus 1 over 2 is 3.5, it is 7 over 2. So t 7 over 2 is equals to tn. Again, since the base numbers are the same, we can cancel them out, and we're left with 7 over 2 equals n, and that's our answer.